For this first proof example in 5.4 day 1, we're going to prove one of the multiple angle identities. So we're going to prove a multiple angle identity using previous identities. So it's kind of like a definition in English. Your English teacher would probably tell you when you're defining a word, the only word that you can't use in the definition is the word that you're defining. So same thing goes for this. We're going to try to prove that this is a true identity without actually using one of the double angle identities. So this comes from the double angle identities. But we're not going to be able to use that identity to prove itself. What we're going to do is actually go for the sum and difference formulas down here. So like before, we do have to start with one side of the equal sign to do our proof. Remember, we always, when we're proving something, we start from one side, either the left or the right, and we just work with that one piece at a time. So I'm going to start with the left-hand side here. I'm going to start with the cosine of 2u. Now, in order to make this work out using one of the identities, these are sum or difference identities, so I have to translate this into something that involves plus or minus. An easy way to do that is to call it cosine of u plus u. Now, once I have it in this form, I can pretty easily use the sum or difference identity. You'll notice that it's cosine, and so I want to have cosine of u plus u. It looks like that is this one right here. So I'm going to use that identity. I'm going to, next step, just expand it out. So cosine of u plus u looks like we start with the cosine of the first one times the cosine of the second one. They're both exactly the same in this case. And then minus the sine of the first, sine of the second. Okay, and we get that expression. Now, you might notice that we're actually almost done with this problem. The only other thing we need to do is notice that cosine times cosine is cosine squared, and sine times sine is sine squared. And that is what we were trying to prove. That's the right-hand side of that problem. Again, I want to just remind you that when you write cosine squared or sine squared, that means the same thing as saying cosine everything squared and sine everything squared. It is not a square on the variable itself, it's a square on the entire thing. So that's just a side note. This is the actual proof, but I want you to remember that, as that's a really important fact for when you are using trigonometry later on in calculus if you go on to calculus.